All right, let's see. So we've got, whoops, where am I? Okay, we are looking at, let's start with the solid ball of radius 1 centered at 0, 0, 1. Well, that's not that different from the one we just talked about. So here's the, there that is, right? Yeah. And the center is at 1, the radius is 1. Okay. And we want the part that's, let's see here, outside of the unit ball, and the unit ball on this picture would look something like, oh, come on, doing that. Something like that.
Can I ask a kind of silly question?
Sure, sure.
What is the difference between a unit ball and like a
unit sphere?
Yeah.
Okay, so it's a great question. A lot of students don't know the difference. It's a kind of a matter of convention, right? But the standard convention in math lingo is that a ball is a 3-dimensional solid, and a sphere is a 2-dimensional surface. Yeah, does that make sense? You have to distinguish between these things because they are different things, right? I mean, if I talk about the surface of the Earth, for example, that's just a surface. Right. Whereas if I talk about the Earth, that's a solid. The Earth is not just a surface.
Oh, so the sphere is talking about like the actual surface.
Yes.
Like kind of hollow on the inside.
Yes.
If you will. Okay.
Yep. Absolutely. And so you see why we have to distinguish between them, right?
Yeah.
So they're different things. So the in common lingo, people say ball and sphere kind of interchangeably, but just in math, we need to distinguish these things, and so we try to get particular about it.
Okay.
The 2-dimensional equivalent of this, the 2-dimensional analog of this, is that the 2-dimensional inside of a circle is called a disk. The circle is just the 1-dimensional boundary of that disk.
Oh my God.
Yeah,
Wow.
yeah. Again, we would distinguish. Yeah, right.
Mind-blown.
Yeah, right. Yeah. So again, in common lingo,
Because I think a disc like a CD disc.
Right.
That's
Right.
like,
Right. Yeah. Well, yeah. Exactly. I think frisbee, but yeah, totally.
Yeah.
Okay. So, all right. So we're interested in the part of this. Let's see, the part of that ball that's outside of the unit ball, and so we have this picture. Is that what you were thinking?
Yeah, that's what I'm doing.
Okay. All right. So, so let's start thinking about our slices. Now, let me. Whoops. Sorry. Let me get the thing here. We're going to be doing a triple nested integral. There's going to be some integrand. Oh, let's write that. What's the integrand? 3x minus 2y plus e to the z. Okay, fine. And then our volume form. And don't forget rho squared sine phi d rho d phi d theta. Write all that down first so we don't forget the stretching factor. All right, so one at a time then. What is the range of values of theta? Well, theta goes all the way around, so 0 to 2 pi. Is that cool?
Yeah.
Next, now we're going to fix a value of theta now. Like so. Now here comes the art challenge to actually draw what this looks like, right? And part of the problem here is the picture I've drawn is already bad. I mean, you imagine a solid ball, and I haven't drilled a cylindrical hole through it. I've got a dent in the bottom. So there's really a certain amount of yellow. Let's see here, yeah. I mean, that's kind of the bottom lip of this thing. So there's really some of my solid is actually down here as well. It's just that's where the dent is taken out above. So yeah, you can kind of tell. So it's, in other words, you're looking through less solid there and more solid up there. Does that make sense?
Yeah.
Yeah. Okay. So in this blue plane here, let me take a whack at drawing what the cross section in this blue plane is. And it's something like something like that. here, why don't I shade it in with blue here. So that's my theta cross section. How are we doing? Everybody happy?
Yeah, I just didn't really know how to find the balance.
Yeah. No, we're getting there.
Okay.
Yeah. Okay. So, right. So now what is our next question? Our next question is the range of values of phi. Oops. Okay. Well, there's the sort of the first phi slice, and the last phi slice is going to be, well, it's going to be a point like that. Right, and yeah, it's hard to see on this picture. You know what's going on. Where is this? It's hard to keep track. So I'm going to play my usual trick, and I'm going to draw that phi slice over here, looked at head on, so that I don't have perspective problems.
Okay.
And okay, let's see here. Oh gosh, I guess I'll do this all in the blue. This is what that cross section is.
So are you kind of just like rotating that plane to...
I'm rotating this shaded blue area around the z-axis effectively. Conveniently, everything in sight's rotationally symmetric around the z-axis.
Okay.
Is everybody good?
Well, like, where is that picture viewing that from?
This blue picture here?
Yeah.
What I'm doing is that's looking exactly at this, just seen from sort of, seen from kind of what would be straight on it. In other words, I don't want to draw it in perspective in 3 space because it just makes it hard, right? Okay, so looking at this picture then, I'm going to make a couple of clever observations, and that is I'm going to draw 3 lines whose length is 1, each of which has length 1. Okay, that has length 1 because it's one of the radii of my top circle. That has length 1 because it's a radius of the bottom circle. That has radius 1 because it's a different radius of the top circle. So what I have there is an equilateral triangle, and that tells me all the angles are pi over 3. And so conveniently, the range of values of phi that I'm looking for, that's where phi starts as 0, and that makes this clearly pi over 3.
Okay.
Yeah. So this is another one of those things where, the question is not, man, I never would have come up with that on my own. Right? The question is, now that you've seen it, can you just remember the trick that you look at it from this point of view, look for what information do you know about the point, and it's just you put this as a tool in your toolbox, and make sure to remember how to do this kind of thing.
And then to find rho, would you have to solve for rho?
Yep.
With the 2 bounds.
Well,
so you would solve for rho for the unit.
Let's do that. Got it. Wow, I didn't think I could do that. Okay, so so for a particular value of rho here, let's see here. So there's a particular, a phi. There's a particular phi slice, right? And on that phi slice, let's now ask, where does rho start? Well, rho starts at that point. That point is on that curve, which came from this surface. And you got to ask yourself, what's the equation of that surface? And solve for rho. And conveniently, that surface is just rho equals 1 because it's the unit sphere. So we start with rho equals 1. Everybody good so far? Okay. Okay. Next, we end, in other words, with. I'll do this in red, I guess. And at that point is on that curve, which came from that surface, which is a little spherical coordinates problem.
Okay.
Right, you know how to do that?
Yeah.
Yeah. So,
and then
write
the
this.
final
Yeah.
integral, do we have to put X, Y, and Z in spherical coordinates as well?
Yeah. Absolutely. You got to convert all the rectangular stuff to polar, to spherical. Sorry. Yeah. Right.
Okay.
Everybody good?
Yeah.
Okay. Next question. Okay. Give me 2 seconds. Let me stop this recording.